Good afternoon, everyone. It is my pleasure to welcome you back to another season of Webinar Wednesdays brought to you by the Canadian Associates of Ben-Gurion University. And through the magic of 21st century communication, I am actually in Israel as we speak, and so lucky to be here. This is the first time in almost 2 years that I have both traveled at all and traveled to Israel in particular. Since May, we at CABGU have been working tirelessly on creating a lineup of exciting and engaging events that are thought-provoking, informative, and which highlight the high caliber of researchers, staff, students who call BGU their home. Today, we're kicking off our Webinar Wednesday series, version 2.0, with a very special hour-long event featuring the work being done by the National Autism Center at Ben-Gurion University, which only recently has been renamed the Azrieli National Center for Autism and Neurodevelopment Research. This fantastic name change is the result of a transformational donation of $15.6 million Canadian, which we have received from the Azrieli Foundation. This only reinforces the outstanding nature of the autism research at Ben-Gurion University and the great respect and friendship between the foundation and the university. Before we delve into today's webinar, it is my pleasure to introduce a very honored guest who has a special message to share or to speak about. The chair of the Azrieli Foundation and an important friend, Dr. Naomi Azrieli. I had the pleasure and luck to have worked for the late David Azrieli, who was a true visionary and brilliant man, and I can tell you that his children are just as special as he was. Naomi, the screen is all yours.
Hello, everyone, and welcome. I'm really delighted to be with you today. So, as you've all heard, the Azrieli Foundation recently announced major support for the National Autism Research Center of Israel. We have been so impressed with the collaboration between scientists from Ben-Gurion University and clinicians from Soroka Medical Center. The new center, through its innovative, holistic approach aimed at translational research, will revolutionize diagnosis and interventions for people with autism and other neurodevelopmental disorders. We are so honored that the new center has been renamed the Azrieli National Center for Autism and Neurodevelopment Research. Now, about 10 years ago, we made a strategic decision to invest in brain research. The brain, through its interconnected system, is really the final frontier of human discovery. It is, as many of you know, the most critical organ in the body, and yet it is also the least understood. As researchers continue to explore the brain and its complexities, the need for high-impact research also continues to evolve. The solutions to challenges in science, in health, and in our communities lie in the connections we make with each other, often at the boundaries of fields and disciplines. We believe that it is imperative to support a continuum of research and care, from the laboratory bench to the bedside and back. And we are confident that the new Azrieli Center will do this. The challenge of discovering innovative ways to help people with neurodevelopmental conditions like autism requires a network of committed people, patients and their families, researchers and clinicians, philanthropists, and the government. Today, you will hear about the exciting discoveries ahead. Now, I could talk about that as well, but I'm going to leave that to Ilan and Idan. Instead, I'd like to tell you that while it is a key part of our mission to support innovative and world-class research, we know at the end of the day that it is all about the people. I want to emphasize that. We never lose sight that people stand at the end of every scientific journey. Now, our own particular interest in scientific research stems from a personal reason. Members of my family have Fragile X syndrome. This is a neurodevelopmental condition, and we have made it a goal to help enable the discovery of treatments. So I speak from the heart when I say that we never lose sight of the fact that the goal of the amazing scientific work we support is, at the end of the day, about the people who will benefit from the discoveries. This belief from our heart, will guide the new center too. Finally, I want to note just how delighted we are that the center is in Beersheba. It is our goal to create more opportunities in the area. We want to see the Negev flourish by developing its educational systems, academic facilities, and its health services, all in the hope of creating an inclusive and equal society in Israel. The research and work of the new Azrieli Center aligns with our core priorities. At the Azrieli Foundation, we help people maximize their potential by connecting them to resources, expertise, and education. And the new Azrieli National Center for Autism and Neurodevelopment Research will do exactly that by building and nurturing networks which enable research and treatment breakthroughs. I am so excited to see what lies ahead. Thank you.
Thank you so much, Naomi. We are deeply grateful for your friendship and the generosity of your Azrieli Foundation. It is also my opportunity to thank our 4 executive directors, David Burson from Vancouver, Zach Ostrov from Winnipeg, Shimi Wenner from Toronto, and Simon Ben-Simon from Montreal, who, along with Marketing and Communications Director Galit Solomon, comprise the finest team of directors in Canada. They each have worked tirelessly to fundraise and fundraise, and along with our support staff and myself, we have achieved record results for the 4th year in succession. Stay tuned for some more exciting and novel events and programs in the year ahead. Without further delay, I would like to introduce Galit Solomon, CABGU Director of Marketing and Communications, to lead today's webinar. And I bid you actually a very great webinar and a good night from Israel. Thank you so much.
Thanks, Mark, for joining us all the way from Israel, as you mentioned, and welcome everyone to another season of Webinar Wednesdays with Canadian Associates of Ben-Gurion University. Joining me live from Israel is Professor Ilan Dinstein, who is the director of the newly named Azrieli National Center for Autism and Neurodevelopment Research. And also with us today is Professor Idan Menashe, Associate Professor at the Public Health Department at Ben-Gurion University. Welcome, gentlemen.
Thank you, Galit.
Professor Dinstein will be our first presenter, and before he begins, I would like to share a brief biography. Professor Dinstein is an associate professor in the Psychology and Cognitive and Brain Sciences departments at BGU. He received his PhD from the Center for Neural Science at New York University in 2010, and then completed postdoctoral training in the Neurobiology department at the Weizmann Institute and the Psychology department at Carnegie Mellon University. His research focuses on the neurobiology of autism with a particular emphasis on early development. He is the director of the Azrieli National Center for Autism and Neurodevelopment Research, as I mentioned, which collects vital information from hundreds of children with autism and their families with the goal of improving autism diagnosis and treatment. And Ilan is also the very accomplished jazz and rock drummer of the Ben-Gurion University excellent band of musicians who are all top researchers. Professor Dinstein, the screen is yours.
Thank you so much, Galit. And thank you also, Mark and Shimi, for organizing this wonderful webinar, and of course to Naomi Azrieli for this amazing opportunity. It's both a great honor and a big responsibility to take on this national effort and really transform Israel into a leading entity in the autism research domain. And what I'd like to do today is both give you a little taste of what we do. I'd like to tell you a little bit about the way we do things and this unique framework that we've created in Israel. And then I'll give you a few examples that are oriented towards technology. And then Idan will take the stage and tell you about some other topics. Understate the necessity and the importance of this multidisciplinary effort. So we have scientists coming from many different fields, and neurologists and radiologists and computer scientists and many other folks, both on the BGU campus and also in other universities in Israel. And you might ask yourselves, why do we need so many different types of expertise when we approach autism research? And the reason that we need all of this is because autism is an incredibly heterogeneous disorder. And it's actually my intuition that in a few years, we will have multiple names for autism. And what you see here in this slide is a depiction of the two core symptoms of autism. So autism is defined by having social communication difficulties and by displaying restricted and repetitive behaviors. But it actually is composed of a whole host of other symptoms that include things like anxiety and sleep problems and ADHD symptoms and language delays and different cognitive abilities and so on and so forth. And the reason I show this is because it's imperative to understand that different individuals with autism have different capabilities and different challenges. And when we approach this topic and think about how to improve their daily lives and how to advance things like diagnosis and treatment, we have to understand that there isn't going to be a single solution for everyone. The individuals are different and they're going to need different solutions, both in terms of diagnosis and treatment. And in order to do that, we need to approach this issue from multiple angles, because for some individuals, diagnosis and treatment will be improved by looking at their genetics. In other cases, we want to look at biological markers like things that we can see on ultrasound scans or maybe on MRI scans. And Idan will tell you a bit about ultrasound scans later on. We can use different types of technology to make progress in these fields. But again, different types of technology will work for different individuals, right? So we keep on thinking about this issue of what will work for whom. And this is one of the main motivations for building a national center and for doing this kind of research on very large scales. Because in order to understand the heterogeneity, we need to understand a large population and understand how symptoms and treatments work on large numbers of children and adults with autism. And what I wanted to do is to give you a brief overview of how we do this kind of work. And a really important aspect of this is the collaboration, not only between scientists, but also between scientists and the medical community, which is, it's rather surprising, but it's remarkable that there are very few centers in the world that work on autism that are integrated into the clinic where autism is actually diagnosed and treated. And that is one of the huge advantages that we have in Israel, where we've incorporated ourselves into the social healthcare system where people with autism are treated. And we actually do the research inside these locations. And that will be clearly evident in the following video clip. Here we go.
In 2018,
Oops, I think we got stuck on the video clip. Hold on, let me try and share it again.
Israeli Ministry of
In 2018, the Israeli Ministry of Science and Technology announced a grant to create a national autism research center. The grant was awarded to scientists from Ben-Gurion University and physicians from Soroka Medical Center, who had developed a unique model that integrated scientific research into the clinics where autism is diagnosed and treated. Every year, 1,800 new children are diagnosed with autism in Israel, in 40 medical centers. Approximately 180 of these diagnoses take place in Soroka Medical Center. The diagnosis of autism requires multiple visits, in which clinicians interview the parents and directly assess the behavior of the child. By integrating the research into the diagnosis visits and later follow-up visits, scientists at BGU are able to collect a wide variety of data from a large number of children. This data includes detailed information about the child and family from the Soroka electronic patient record system, behavioral information from voice and video recordings of the child during interactions with the clinical staff, parental questionnaires about sensory sensitivities and sleep habits, saliva samples for genetic testing, blood samples for metabolic testing, eye tracking while watching TV, and even EEG recordings during sleep. As of May 2020, the national database contained information from over 1,000 children with autism and their family members. This research is unique and extremely rare on a global scale because it combines a wide variety of data from each of the children that is captured at the earliest stages of their development, when autism symptoms are first emerging. Today, scientists around the world agree that autism is not one disorder, but rather a family of distinct disorders that are likely to have different causes. By combining multiple types of data, the interdisciplinary team at the Negev Autism Center hopes to identify these distinct subgroups of children and match each subgroup with the most efficacious targeted treatments. The National Center is expanding these activities to additional medical centers throughout Israel. This expansion enables researchers across the country to identify the most effective diagnosis and treatment methods for autism, to develop new diagnosis technologies and medical interventions, and provide reliable and scientifically based advice to government officials. In parallel, the center is building a national research community that includes physicians, scientists, therapists, parents, and adults with autism. Hundreds of community members come to the annual Israeli meeting for autism research that is held at BGU. These efforts are transforming Israel into an international leader in clinical research that is focused on improving the quality of life for individuals with autism and their families.
Great. So I hope you got the gist of it, and again, emphasizing the large-scale effort that's at hand here. And just to demonstrate that we're not working alone, I wanted to show you this depiction of our database. The database is really the cornerstone of this effort because that's where we collect of that large amount of information from different children with autism and their families and bring it together and make it accessible to scientists throughout the country. And so we recently published a paper where we showed the plan for this database, and we did it together with 45 of the leading researchers and clinicians throughout the country. And this is really a collaboration that's, in a scale that's practically unheard of in Israel. And so we collect a wide variety of different types of information that we can use for different purposes. And as I mentioned, our focus is on diagnosis and treatment. In previous webinars, we spoke about treatment. We talked a bit about medicinal cannabis, which is an interesting form of treatment that's being researched by us and others in Israel. And today I want to focus on examples that have to do more with diagnosis and with technology. So we have this immense amount of information about kids with autism. How do we develop new technologies that will help us perform diagnosis better? And the answer with technology, you know how in Israel we're all excited about being a startup nation. There are amazing human resources in the fields of computer science and biomedical engineering and related fields. And one of the really interesting avenues of work we can do here is to use things like computer vision and analysis of speech, of recordings of kids with autism, in order to try and quantify their autistic symptoms. And so we do this in a variety of flavors. I'll show you a couple of examples. What you see here on the left is an image of one of our behavioral assessment rooms. So what we do is we spread these recording systems throughout the clinical centers in Israel, and we actually record with high definition video and audio systems during the diagnoses meetings where the child comes in and meets with the clinicians and undergoes a variety of behavioral assessments. And this information is really invaluable because we can then start measuring, we can quantify the behavior of the child in the room in ways that are very exciting. So I want to show you a couple of examples. This is one of our behavioral assessment rooms. You see this rug on the floor with toys and kids like to play. So what the clinicians usually do when they try to get a feeling for their capabilities and behaviors is they play with them and they try and be their friends. And when they do this, it looks something like this. So here what you see is a clinician who's interacting with a 7-year-old girl who's being assessed for autism. And you can see that with these kind of unique cameras, here you see the parent at the bottom. What we can do is we can track the location of the child, who is now approaching the parents for a second and then returning toward the clinician. And what we do is measure things like the amount of time that the child approaches the clinician, the percentage of time that they avoid the clinician. We can also look at the distance between the child and the clinician throughout this period of time. And as you might imagine, children who have more severe autism symptoms, they tend to shy away from the physician, from the clinician. They tend to avoid them. They also tend to look away. So another interesting measure that we have is we're able to identify the direction of gaze of the child and determine whether they're looking at the clinician and trying to engage them or not. Okay? And so these kind of measures are very helpful when you think about quantifying the severity of symptoms, and the point here is to aid the clinical team in making a more concrete and reliable decision regarding each child. And as what you see down here are some clinical assessments. We don't have to get into that, but these ADOS scores, ADOS is the clinical gold standard for determining whether a child has autism. The higher the score, the more severe the symptoms according to the clinician, and we can estimate with reasonable accuracy some of these severities according to the measures that we get from the video clips. And so the concept here, it's not that a single measure is now going to determine whether a child has autism or not, but we're building a toolbox of multiple different measures. Okay, the mean distance from the clinician is one of them. And together, these multiple measures are going to give us a perspective or an estimate of the severity of the autism symptoms. So that's one measure. Another measure has to do with stereotypical movements. So many children with autism perform stereotypical movements like hand flapping and spinning around in circles or rocking their body back and forth and movements like that. What you see here is an example of a child that's undergoing an assessment, and these lines are tied to the skeleton of the child and basically allow us to quantify the movements of the child. And this is a very unique situation where we can create computer vision algorithms that can identify stereotypical movements. And the kind of movements that we're looking for are things like hand flapping, playing with an object repeatedly, like twirling a wheel of a car, of a toy, tapping, jumping in place, things like that. And what we find is that, of course, different children present or exhibit different types of stereotypical movements, and they also do so to different degrees. So some children exhibit stereotypical movements for less than a minute during the ADOS, while others might present it for 10 or 15 minutes throughout the ADOS. The whole ADOS is 45 minutes, just so you get a feeling. And here you see some examples of this computer vision algorithm. And we're now in a point where we can pretty accurately identify what you see here as a child rocking back and forth. This is a set of images from the movie. And you can see that the algorithm gives a very high score to this body rocking movement. Whereas here is a child who is flapping their hands, and the algorithm identifies the flapping movement together with some jumping. Now, this is really useful because it allows us to quantify these symptoms. We can talk about both the risk of having autism. Let's say this is the first time we're seeing the child. So the more severe these symptoms come out, the higher the risk or likelihood that they have autism. And we can also do another really important thing. We can measure this over time and see whether the severity changes when we give a certain treatment, or when the child goes through some therapy or goes to a certain educational setting or program, things like that. I'll give you two more examples. This is a project that I'm very proud of, where we're integrating the same kind of systems into a daycare center, which is also, I think, one of maybe the first in the world, where we've integrated cameras into the cubicles where kids with autism sit with their therapy, with the therapist. Here you see a kind of behavioral intervention where the therapist is trying to teach the child about different types of fruit and teach them the words. And what we do is we record the children over extended periods of time, over months, and see how they respond during these interactions. And this gives us a lot of information about whether they're improving in this educational setting, or God forbid, are deteriorating, and whether they're expressing themselves more with facial expressions, presenting stereotypical movements, and other different types of symptoms. The last example I wanted to show you before we switch over has to do with eye tracking, which is another really useful tool. Here you see an example of one of the children in our center sitting in front of a TV with an eye tracker here at the bottom. And what we show them are different movies. One of them is actually of my family. So now you'll get to meet my daughters. So this is a few years old when they were younger. And each green point that you see here on the screen is a different child with autism who's looking at this movie. Okay, and you can see that they're interested in my daughters. And in a moment, you'll see a loaded social interaction between my daughters. And by the end of this movie, you'll be able to tell me who's the boss in our home, right? And this is intentionally an everyday scene, right? With a lot of social content. There's a lot of emotion here in a setting that has, this is a messy room. There are other alternatives where you could look at other things in the background. And the big question is, how do kids with autism look at this movie? And do they look appropriately at the locations on the screen where the social information is available? Because if children don't look at the right places, they're not going to be able to learn social interactions properly. As children, we need a lot of time to learn how to interact, and we need to learn the meaning of different actions and their social consequences. And what we find in this kind of research is that while we also show this to typically developing kids, and while the typically developing kids tend to agree on where they need to look at when they're watching this movie, we find that at least some of the children with autism, about half of them, disperse and look at other things that do not seem very relevant. So just to illustrate that, here's a single frame from that movie. You see these green dots, which present the eye fixation of children with autism that are totally off in unwarranted locations, right? And we can quantify that throughout the movie. And we find that about half of the kids, particularly this naturalistic movie is the movie I just showed you of my daughters, that is the most useful movie for separating kids with autism from typically developing kids, because the kids with autism tend to look at other things throughout the film. And so this gives us another angle. It's a very reliable measure. We can measure it once and then again, we get the same results. And we can identify, again, here in the green dots, you see the individual children, those who are further away from where the typically developing kids are looking at, the ones with the large mean deviance are the ones with the high ADOS scores. So that again gives us a quantification of the severity of the symptoms. So with that, I will end my part of the presentation. I hope I gave you several useful examples for how technology can be used to help and aid the different clinical teams and help us understand how treatments are working and for whom. Thank you.
Absolutely, you did. Thank you so much, Ilan. We will be hearing again from you during the Q&A portion of today's webinar. But first, I would like to share the biography of Professor Idan Menashe, who is our next speaker. Professor Menashe is an associate professor at the Public Health Department at BGU. He leads a unique interdisciplinary group that studied the genetic epidemiology of autism with a focus on genetic and non-genetic or environmental risk factors of autism, identification of early biomarkers for autism, and understanding factors contributing to health disparities in autism diagnosis and treatment. Professor Menashe serves as the scientific director of the Israeli National Center for Autism and Neurodevelopment Research, and as the Israeli representative at the Global Senior Committee of the International Society for Autism Research. To date, Professor Menashe has published over 70 articles in high-impact journals. Professor Menashe, the screen is yours.
Thank you, Clalit, for a very kind introduction. Let me share my screen. So it's a great pleasure to be here and present our work from the Genetic Epidemiology Lab of Autism. In my lab, we study we conduct two major types of studies. One is to try to understand the causes and risk factor of autism, which involve both genetic and non-genetic risk factors. And the other type is trying to identify early biomarkers for autism. For both of these studies, we use the very unique database of the National Autism Research Center of Israel, and we integrated with data that we collect from Soroka Hospital and Clalit HMO. Because we take advantage that about 90% of the children in our center were born at Soroka and continue to get medical treatment at Soroka and its outpatient clinics, which means that we have access to a huge and very comprehensive medical data about these children, their siblings, and other children in the Negev. We use this data to conduct our studies in both of these studies. And I show you one example of a study that we looked for risk factor for autism using these data. So in this study, we actually looked for prenatal or perinatal risk factors for autism. And we were using this unique data, we were able to show that exposure to general anesthesia probably contribute to the risk of autism, or the exposure of general anesthesia during this cesarean section probably contribute to the risk of autism, irrespective to the indication of the surgery. We were actually one of the first to show that, and this kind of association is taking more attention recently. So this is one example of a study of risk factors of autism. We continue to study other risk factors, prenatal risk factor, but in today's presentation, I want to focus on other studies that look on early biomarkers for autism. When you think about early biomarker of autism, you might envision this chart of child development. On this chart, we can put the autism diagnosis, which usually takes place sometime for most children, sometime between the age 2 and 3. Because at these ages, the core behavior symptoms that Ilan already talked about of autism are clearly manifested. So it's relatively easy to already diagnose these children at these ages. However, many studies already showed that earlier signs of abnormal development appear earlier, sometimes within the second years of age. And these abnormal developmental signs are used by several different screening tools for autism. One of the most common of them is called the MCHAT. In addition, as Ilan already presented, recent technological advances have shown that they can detect even earlier signs of autism using these technologies. One of them is the eye tracking, and they propose that they can detect these abnormal neurological signs in children with autism at the age of about 6 months. Some other studies reported that some children with autism are born already with some anatomical abnormalities. One of the most major ones are abnormalities in the head side, in the head circumference. So these abnormal anatomical signs that children are born with suggest that maybe some of these signs emerge during pregnancy in utero. So in our study, what we try to ask is whether we can detect some similar early signs or early biomarkers for autism during pregnancy. And actually, we have a very good tool to do that, which is the prenatal ultrasound, fetal ultrasound, which is a commonly used monitoring tool for the fetal development, which most physicians are using to survey for fetal growth and development, to look for some abnormalities in organ development and so on. So it was very surprising to us to see that almost no one looked on these data and asked whether he can find early biomarkers for autism in these data. So as I already showed you, we collected data from, before that. So in Israel, most pregnant women undergo at least 3 ultrasound scans during pregnancy. And this is because the Ministry of Health of the Health Insurance actually funding these three or more even ultrasound scans. So most women are having several ultrasound scans through pregnancy. So we took the advantage of looking at these scans and asked whether we can see some early signs of autism in these scans. So the study goal, the goal of these studies that I'll show you in a minute, was to try to identify fetal biomarkers for autism in ultrasound scans. For that, we looked on the children with autism in our database and asked who has data from fetal ultrasound scans in the Clalit HMO database. about half of these children had some data from their ultrasound scans in the Clalit HMO. And then we also collected data from their typically developing siblings of these children for the reason to account for familial factors that also can cause or contribute to abnormalities, to fetal abnormalities. And another control group was randomly selected children from the general population that we also had their ultrasound scans. The first study that we did is to follow the indication that some children are born with abnormal head circumference, and most of them were born. These are just examples of two studies that showed that children with autism are on average having a smaller head circumference at birth. So we ask in this study whether we can track this abnormality in head circumference earlier in life, actually during birth. For that, we use data from two ultrasound scans, biometric ultrasound scans that are conducted during the second trimester and third trimester of pregnancy. These scans are usually used to monitor the fetal growth, and they take several biometric measures of the head and the legs and the abdomen to try to estimate the fetal weight and the fetal height and the overall growth of the fetus. And we compared these data between these three groups. So it's a little bit difficult to see in this chart, but what we found in this comparison, we actually identified several very exciting findings. First of all, I think we are the first that showed that there are significant differences in biometric measures between males and females in general, irrespective of autism. Actually, the growth charts of fetuses don't distinguish between male and females. And our findings suggested that someone should do that, because earlier studies that try to find early biomarkers for this, and there are only few of them, didn't separate males and females, and therefore their finding was heavily biased by the male-female bias of autism, which is a 4-to-1 males to females of children with autism. The second very exciting finding was that we showed that children with autism and their sibling having a smaller and narrower heads during the second trimester. You can see that these dots here that measure the BPD is the head width, is significantly smaller from the typically developing children from the general population. However, while the siblings of the children with the autism managed to close the gap during the third trimester, the children with autism remained with a smaller head and probably were born with smaller head as we showed before. So these findings suggest that the smaller head circumference, or actually smaller and narrower head, as you can see in this picture, might be like a biomarker of autism, not only at birth, but much earlier during pregnancy. In a second study that we conducted, we want to go deeper in terms of the types of biomarkers that we're looking. So we looked on other anatomical abnormalities in the fetuses. And for that, we used data from the late anatomical server, which is actually a server that is designed to detect fetal structural anomalies and what we call soft biomarkers or soft markers that may develop into a congenital malformation in the children. Again, we compared these three groups. In each group, we already had more than 200 individuals with ultrasound scans. And what we identified, what we discovered was amazing. First of all, we found that children with autism have significantly higher rates of fetal anomalies. If we compare them here, the children with autism are marked in black, their sibling in gray, and the typically developing children from the general population in white. So we can see that children with autism have twice as much as fetal abnormalities than their sibling, the typically developing sibling, and 3 times more than other children from the population. So it means that fetal abnormalities, anatomical abnormalities, are significantly exist in higher rates in children with autism. Then we asked, okay, in general, we have more fetal abnormalities in children with autism. Where, in which organ these abnormalities exist, presented? So we looked on the different organs, and you can see here the same, the colors are the same. You can see that most of the differences between children with autism and children without autism appear in the urinary system and the heart. Obviously, you can see that in almost all other organ systems, there are differences, but the most significant differences were in the heart and urinary system. So we conclude that different fetal organs anomalies are associated with autism. And most importantly, we can maybe use these fetal anomalies specifically in specific organs as a prenatal biomarkers for autism. So we can detect early signs of autism as early as in the 2nd trimester of pregnancy. What we are planning in the future. So in the future, we are planning to integrate these ultrasound data with genetic data that we have for these children in our center, and with clinical data about congenital anomalies and other comorbidities about these children, and trying to understand the etiological pathways from specific mutation to the specific fetal ultrasonography markers to the actual congenital anomalies in children with autism. And these congenital anomalies in all these data actually can help us to define very specifically different types of autism defined by all these data. Here I show you some preliminary findings where we try to do that. And what we did is to compare the genetic mutations in these children between children who present some fetal anomalies and children who doesn't present any, children with autism without any fetal anomaly. And you can see that if we look on mutation in non-autism genes in our sample, they are much more prevalent in children that present fetal anomalies during pregnancy than children without any fetal anomaly. This suggests that indeed these there is a link between specific mutations associated with autism and these specific fetal anomalies, which is very encouraging. And in the future, we will try to also connect it to specific congenital anomalies. Before I forget, I want to mention that all this amazing work was done by my PhD student, MD PhD student, Oad Regev, and my other exciting thing. And that's it. I'm happy to answer any questions.
Wonderful. Okay, we'll bring both of you back on screen. Professor Dienstein, Professor Menashe, thank you both for your presentations. As you can probably see, there are quite a few questions lined up for us, and we're going to get to those. A reminder to everyone who is in the audience, if you do have a question that you'd like to share, please do so in the Q&A box. And I'd like to begin by asking you, perhaps Professor Dienstein, we'll start with you, asking you about the overall impact of that $15.6 million gift from the Azrieli Foundation and the impact that it's going to have on the National Autism Center. What does this donation mean to you as researchers and also to the greater community?
So this this donation is really transformative. It's really going to change the way we do autism research in Israel. We are, as part of our plan, we are creating a national network of sites, and this is all going to be about partnerships with the different HMOs who are treating the children and diagnosing the children, partnerships with other universities where there are other important researchers who need access to the data that we're collecting, and creating infrastructure that can be used by multiple researchers in Israel to really push the field forward and create a somewhat of a revolution in Israel. So it's really transformative in that this is bringing everyone together. And I think that's key to making any progress.
And just as a follow-up to that, just because it's our second question in the Q&A queue here, in relation to the same donation, what can we expect in terms of global partnerships? Is this something that you're considering as well?
Of course. So we're actually, as really have several autism centers in Canada. We've already started discussions about how we can collaborate. It's going to be extremely interesting to see whether the kind of findings that Idan just showed you are apparent in populations of other countries like Canada and the United States. We're in very close touch with all the major autism research centers in the world. And it's really, the time is ripe for creating these international collaborations and identifying what's similar across countries, what's different across countries. It all goes back to that question of heterogeneity and how can we figure out what are the diagnostic and treatment solutions that work for different individuals.
Okay. We'll start taking some questions from the audience because we've got, like I said, quite a lineup here. Michael Sachs says, good morning from Vancouver. The last webinar you did focused on the CBD studies conducted at the center. Is there any updated information for this topic? And again, this particular topic was discussed, I believe, by you, Professor Dienstein. So I'll address that to you.
So the update is that we finished looking at data of 100 children and adolescents. They were between the age of 5 and 25. This is a collaboration with a group in Asaf HaRofeh Medical Center. This was an open label study, just to remind you. And what we found there is that the CBD had a consistent, significant positive effect, particularly on the social interactions of the kids and adolescents who took it. And so that's very encouraging. I want to qualify that statement. So the use of CBD is generating a lot of excitement, but we really also need to perform double-blind placebo-controlled trials. There's a big impact of placebo. Parents and physicians and researchers want to believe that what we're doing is helping, and we need to step up this effort. And so Idan and I, together with Dr. Gal Meiri, are now on the verge of starting such a double-blind placebo-controlled study at Ben-Gurion and Soroka Medical Center. And I hope we'll be able to convince again that the findings are positive. We'll see.
Very good. Thanks for that. Professor Menashe, I'd like to address the next question to you, and it comes to us from Dr. Keith Meloff. He's a pediatrics and neurology doctor in Toronto. And he says, I have a suggestion. I think it is important to know when an infant learns to form a kiss with the lips and mouth as a biomarker for future speech development. The literature on this developmental milestone is meager at this time. So I know you deal with more of the technical side of things. Is this something that you've explored? And if so, and even if you haven't, what are your thoughts on it?
So this is a very interesting thought. I never heard about that. We actually do some studies about the early developmental milestones, and I mentioned it briefly in my talk. so we use that the common developmental milestone and look how they can predict or be associated with autism. I never heard about the KISS as an early developmental milestone, but I'm willing to explore that.
Very good. And Ilan, do you have any thoughts on this as well?
Yeah, no, it's making me think as we talk about it, you know, do all children perform the kissing mannerism? That's an interesting point. We usually look at, you know, the standard measures are walking, crawling, you know, all the behaviors that are very evident, but actually the kissing motion should be apparent to parents. So.
Okay, so Dr. Mello, thanks for that idea. Maybe our researchers will run with it. Shula Klinger from Vancouver, one of our board members, asks, I have noticed that children with autism have an unusual way of speaking or an accent that nobody can quite identify. In English, it presents in the R sound. It is more of an wa, I guess, or a W. Are you working with speech and language pathologists? Would love to know where this originates.
Yeah, so maybe I'll take that. We work, I think most of our staff are actually speech pathologists. We spend a tremendous amount of time looking at thinking about speech. I didn't show you that avenue of research, which is also based on technology. We're working with the audio recordings from the assessment room. So we record, about half of the kids are verbal, half are not. We record their vocalizations and we analyze them with a variety of speech analysis tools. And in the same way that we can identify repetitive behaviors and stereotypical movements and other types of autism symptoms, this is a super interesting area of research. We're at the point now where we can predict autism severity with very high accuracies just based on recording the speech of particularly the verbal children of that half. There's a lot to do there. You know, we could talk about that for an hour.
Right. Maybe that'll be our next topic when we invite you back. Leslie Warren asks, is there research about potential links between autism and a prevalence of autoimmune disorders in families? And I'll open it up to both of you.
So maybe I'll take that. Yeah.
So
we are now actually finalizing a study about any kind of like a link between the immune system and not only the autoimmune diseases. And obviously there are several interesting findings, and not necessarily about autoimmune disease in the family, but other types of let's say failure of the immune system or some other types of diseases that affect the immune system with autism. So this is very preliminary data, so I can't really reveal all the results, but we certainly see some link between the immune system and autism.
And Professor Menashe, I know that you mentioned earlier in your presentation as well about C-sections and the connection there as well. So we have a question here from Elon Benjamin, and he asks, is there any data on the genetic transmissibility of autism from parent to child?
So this is a $1 million question of autism. So this is very amazing that studies shows that autism, that the risk of autism has a major genetic factor in it. The heritability of autism is estimated somewhere between 50% to 90%. However, when we look into the gene, into the DNA, we find it very hard to find mutation, and actually heritable mutations. Most of the mutation that we found, that not only us, but many other studies found recently, are what we call de novo mutation. There are mutations that appear in the child, but do not appear in its parents. So this kind of difference between what we know about the heritability of autism and the mutation that we found is very amazing and hard to understand. largest study that we are conducting now with the consortium, we are participating in one of the largest consortium of genetic studies of autism that is called the Autism Sequencing Consortium, that already have data from over than 50,000 families with autism all around the world. We were able to show or to find initial signs of this genetic heritability in common variation, that these variation or genetic variation that exists in almost all individuals or in many individuals in the world, and these different variations have a very minor contribution to the risk of autism. But if you combine several of them together in a single child, he might develop autism because of these combinations.
Okay, I'll wrap up with one more question. We do have several others, and so I think that what we'll do is we'll make sure to send these questions to both of you, and perhaps we can get some answers and get back to our attendees today. But I'll wrap up with a question from Claudia Fairman-Schulman, and she asks, what do you know about stem cell treatments for autism? Any other cutting-edge treatments?
Explosive question.
Ilan, I'll let you answer that.
So there have been several attempts to study the potential treatment effectiveness of stem cells. I forget the precise term, Idan. What do they? What did they use in the Duke University study?
It's pluripotent cells, it's called, but it's basically stem cells, yeah.
So the bottom line is that the serious studies that have looked at it have not shown any benefit of using stem cells for kids with autism. There are places around the world, in Panama and in Georgia, that sell this kind of service to families. There are anecdotal reports by some families that it did some, that it had some benefit. There are many other reports where nothing happened. So it's a very controversial topic, and my main advice would be not to get your hopes up when it comes to this kind of treatment. Very controversial. There's no scientific backing whatsoever that would suggest that it works, unfortunately.
Okay. Well,
I want to add to that that one of the reasons that many clinical studies about treating or intervention or treatment for autism are unsuccessful is the reason that Ilan mentioned in the beginning of his talk, that the huge diversity of children with autism. And actually we expect that even for a very effective treatment, only few children will respond to it. And this is the reason why when one is trying to design such a study, he needs to design very carefully and collect only the subtypes or the subgroups of children that he believes that will respond to this treatment.
okay. Our time, unfortunately, is up. Clearly, you've provided us with some fantastic information. And again, as I mentioned, we will get some of the additional questions because there are still 15 in the lineup to both of you, and hopefully we can get some answers for our very engaged audience. Professor Dienstein and Professor Menashe, you are truly visionaries in your fields, and thank you both so much for sharing your knowledge and your insights with us today.
Thank you so much, Galit.
It was a pleasure.
Pleasure having you. A big thanks also goes out to Dr. Naomi Azrieli for your remarks today, and of course the Azrieli Foundation for your transformational donation of $15.6 million. And before we say goodbye, we do have two exciting announcements that we would like to share with you. Backed by popular demand, we're excited to share that our highly successful literary series, In Conversation with Israeli Authors, will be returning in the new year. Sponsored by Indigo Books and Music, we will once again bring you this intimate and interactive experience, and you can enjoy it from the comfort of your home. We will have more details for you in the coming weeks, so please do keep an eye open. And plus, we are also thrilled to announce that our next Webinar Wednesdays event will be held on November 17th, and it will feature Professor Nadav Davidovich, head of Ben-Gurion University's School of Public Health, for an update titled Coronavirus, the Third Vaccine and Beyond. We will be sharing a link to the November webinar in the next day or two. Thanks again, everyone, for joining us. If you would like to learn more about the work we do here at Canadian Associates of Ben-Gurion University, please do check out our website at www.bengurion.ca, or you can also find us on LinkedIn, Facebook, Twitter, and Instagram. Be safe, everyone, and we look forward to seeing you again soon.